In this video I'll be going over the test 3 review. So let's go ahead and get started. It says on number 1, write the interval notation for the following. So -4 less than or equal to x less than 2. I always think of this as x being between -4 and 2, counting the -4 but not the 2. So I use the word between. So we could draw a graph, and the numbers between -4 and 2, counting -4, would look like that with a bracket on the left, because -4 is part of this set and 2 is not, so we have a parenthesis there. And so when you write this in interval notation, it looks very similar. Notice it looks the same on the ends, but instead of shading in between, you have a comma, and that's about it. So this is interval notation for that set of numbers. For x for x less than 1, see, that would be the numbers that are less than 1, so to the left of 1. And we always read interval notation from left to right. So out to the left, that's what we call -infinity, and then eventually we get to right. And again, we use a comma instead of shading, but it looks very similar to what we see on the number line. And all real numbers, just the whole number line. So if you shaded that, if you graphed it, you would just shade the whole number line. On number 2, it says graph the following intervals. So again, it's going to look almost exactly the same on the number line. The only difference is we're shading in between instead of putting the comma there. So again, that's the numbers between -4 and 7, including the 7, but not the -4. Alright, on letter B, we have the numbers greater than -3 or equal to -3. And so we'll start at -3 and go to the right. And so that's the set of numbers greater or equal to -3. Now, number 3 and 4, actually, we're going to be using our equation solving skills. So the CSI. So we don't have any fractions to clear. Whoops, let me change colors here. We don't have any fractions to clear. There's no simplifying to do on either side. But we do need to isolate x on one side, so let's take care of that. And so we get -3x minus 4 on the left is greater than 5. And so this is really like a two-step equation. We're going to want to add 4 to both sides, and we get -3x is greater than 9. And now we divide both sides by -3. And now here's where things are a little bit different with inequalities. We learned that if we divide both sides by negative, we're going to have to reverse the symbol. And so this is going to become x is less than -3. 9 divide -3. And in interval notation, well, let me graph that first. It would look like that. And so in interval notation, it's going to be -infinity to -3. All right, let's look at number 4. So first of all, there's certainly no fractions we need to clear, but we do have some simplifying to do. We got to distribute. So we got the 2 times the x and 2 times the -3. That'll be 2x minus 6. And on the other side, 3 times 2x is 6x, and 3 times 6 is 18. And so now this looks a lot like the one we just did. We need to, now that we've simplified everything we could, we're going to try to get x on one side only. So I'm going to subtract 6x on both sides. I want to keep my x on the left. And so we get -4x minus 6 is less than or equal to 18. And again, we're at a two-step inequality here. We're going to want to add 6 to both sides. And we get -4x is less than or equal to 24. And let's divide by -4. Don't forget, we're going to have to reverse the symbol. So it's x is greater or equal to -6. And that's going to be -6 to infinity. And again, since it's greater or equal to -6, we do use a bracket there. And I would just remind you, again, always use parentheses next to infinity, because infinity is a concept, not an actual number. Number 5. So with these, or what we call compound inequalities, we learn that the goal is to isolate x in the middle. There's basically 3 parts: the left side, the middle, and the right side. So The goal is to get x by itself in the middle. So on the first one here, we need to get rid of the plus 3. So let's subtract 3 from each of the 3 parts. 6 minus 3 is, well, actually, let's do the x in the middle first. So those 3's cancel. We get x. And notice on the right, less than 8 minus 3, that's 5. And if we go the other side, 6 minus 3 is 3. So that's the interval from 3 to 5. So basically all we're saying is if you pick any number between 3 and 5 and you plug it in for x, it will make this inequality true. Alright, let's look at number 6. It's very much like the one we just did. Let's get x by itself by adding 4 to each part. Negative 6 and 4 is negative 2. Of course, in the middle we're just going to end up with x. And on the right side we get 5. And so this is the numbers between negative 2 and 5, including the 5 but not the negative 2. Alright, let's move on to number 7. So now we're going to talk about the composition of functions. And let's see, we read this f of g of x. And in fact it means f of g of x. So the way you say it can help you with rewriting it in terms of what it really means. It means we're plugging the g function into the f function as an input. Well, what is g of x? Well, it's 2x minus 1. So we're going to replace g of x with 2x minus 1. And so now that's my input for the x function. Now look at the x function. We're going to square our input and then have minus 3 times our input and add 5. So I'm going to go ahead and set this up with a skeleton or shell is what I call it. And all we're doing is replacing x with our input, which is 2x minus 1. So we do have some algebra to do here. We're going to have to square 2 of these 2x minus 1s, or FOIL. So I'm going to go ahead and FOIL this out. 2x times 2x is 4x squared. My outer product is 2x minus 2x. My inner product is minus 2x. And negative 1 times negative 1, we're going to get 1. So we end up with 4x squared minus 4x plus 1. So I'm going to go ahead and replace that part there with what we got. Next, we need to distribute the negative 3 times 2x, that's negative 6x. And times negative 1, that'll be a plus 3. And then don't forget to bring that 5 down. And so now it's just a matter of combining our like terms. We've got a 4x squared term. We've got a couple of x terms. Negative 4x and negative 6x is going to be negative 10x. And 1, 3, and 5 is going to give you 9. And so that's going to be our final answer. Alright, so let's look at part B. Now we're finding g of f of x. And one of the things we've learned is that normally they don't equal the same thing. So let's go ahead and find out what we get here. Oh, I'm sorry, before we do that, I want to mention one thing. So notice on the problem we just did, x is your input, and your answer, 4x squared minus 10x plus 9, is your output. Anytime you plug in an input of x, I should say most of the time you're going to get an output that's an expression, an algebraic expression. The other thing I wanted to point out here is the g of x here is what we call the inner function. That's the function that I'm plugging into the f function or into the other function. So we start with that function, we call that the inner function, which would make f the outer function. Alright, let's move on to B now. So this is g of f of x, and that's what it means, g of f of x. So f of x is x squared minus 3x plus 5. And so now that's going to be my input for the g function. Notice the g function, you can see that right here, whoops, is 2 times your input, then you subtract 1. So if I set up a shell, it's 2 times parentheses minus 1, and we're going to plug the input into our parentheses. So that would be x squared minus 3x plus 5. We're going to distribute 2 times x squared is 2x squared. 2 times the minus 3x gives you the minus 6x. And 2 times 5 gives you the 10. don't forget you still have to subtract that 1. And so you're going to end up with 2x squared minus 6x plus 9. 10 minus 1 gives you the 9. All right, let's move on to number 8. So now we're doing a graph. Well, let's see. We have the 1 there, that's separate from the radical, and so that's going to cause us to move up 1, a horizontal or a vertical shift. And notice the plus 3 is inside with the radical, or with the x under the radical. We know that causes a horizontal shift, and these are the ones that work backwards. We're actually going to go left 3. You might have naturally thought it would be right 3, but it's left. It's the opposite of what you might think. So first of all, our parent function here is y equals square root of x. So let's go ahead and plot those 3 points. Remember, we called this the ET function because it starts at 0, 0 and it goes off to the right, kind of like ET's finger. And let's see. So we're going to move this graph up 1 and 3 to the left. So I'm going to start with that point where we start, 0, 0, and move that up 1 and left 3. And notice I end up at negative 3, 1. And so I'll do that with the other 2 points as well. Each point goes up 1 and left 3. Doesn't matter which way you go first. And now let's draw the graph, and it looks like that. So again, that's what we call that ET function. So from left to right, that's how we measure domain, and we look along the x-axis. So at our leftmost point, x is negative 3. And at our rightmost point, well, there is no rightmost point. This graph goes forever right. So we say it goes to infinity. The domain does. All right, the range, we want to go from the lowest point to the highest point. That lowest point is also the leftmost point. It's negative 3, 1 there. So the y value there is 1. Remember, with range, we're looking at y values. And because it goes up forever, there is no highest point. And so it's 1 to infinity. And let's move on to part B. So this time we have 3 things going on here. Notice we have the minus out front, which we know means there's a reflection through the x-axis. So it goes that direction, down basically. And then the minus 3 there is going to cause a horizontal shift. So that's the one that's kind of opposite. It's going to go right 3. And that plus 4 is going to cause a vertical shift because it's totally separate from the function. And so that's going to cause us to go up 4. So here, notice we have the x minus 3 being squared. This is our squaring function, x squared. So let's go ahead and plot those points. Again, you want to make sure you know your points for each of the parent functions. All right, so now first of all, we talk about how we always want to do reflections first. So I'm going to reflect each of those points below the x-axis. So notice this point gets reflected to here. This point gets reflected to here. Notice the origin doesn't move because it's on the x-axis. And so when you reflect each point, you get the 3 marks, or the green marks that I put on there. Now I'm doing things with x's because now I'm ready to get my final graph. I'm going to move each point 3 to the right and up 4. So I'm actually going to move my origin, the point at 0, 0, right 3 and up 4. And that puts it right there. And for me, it's easier to just draw the same shape. So it's going to be a parabola that opens down. Or if you prefer, you can move each point, each of the 5 points, right 3 and up 4. Either way, you should end up with this graph here. So notice our domain going from left to right is all real numbers, our most popular domain. And going from the lowest point to the highest point, there is no lowest point, so we call that infinity. And at the highest point, y is 4, so negative infinity to 4. And I'm going to go ahead and stop the video here, and I'll do the next several problems in a new video.